Today's seminar will cover how to organize, inspect, and summarize asset inspections for utilities. Well, I'm sure many of you have been in this situation. A request has come in to perform a field inspection, and maps are needed to conduct the inspection. In this example, the utility has plotted out their maps, taped them to the wall, so that they can identify where to conduct the survey. On the lower right, you see a paper document used in the field to collect the survey information. As you know, this paper-based field inspection process is still very common within the industry. However, it comes with its own set of challenges. First is trying to keep the information on the paper maps up to date. As we know, the minute the map is printed, it's out of date. Second, is the information on the paper map correct? We've all been in situations where the content on the map is incorrect and it creates confusion in the field. Better yet, the field teams have their own version of the paper maps with markups that they've been collecting for years that never get back to the office, so information is trapped in the backseat of the field trucks. Finally, getting the paper maps out to the field can be very labor intensive, especially if you need to create a brand new set of map books for the field. So the goal is to modernize this process. Technology today allows us to take these maps and deploy them on ruggedized devices, allowing crews to have the most up-to-date, accurate, and timely information. Yet, modernizing workflows comes with a price. User adoption is one of the most challenging aspects of deploying a mobile solution. Field crews have enough challenges getting their job done that they don't need another task that's difficult to complete. So, the solution needs to streamline the workflow, not make it more challenging. Then there's training. The solution needs to be as intuitive as possible. One way to do this is to use devices that people use on a daily basis. Finally, the solution needs to be cost-effective. You want to leverage your existing infrastructure as much as possible to minimize the deployment costs. The ArcGIS platform enables you to overcome these challenges by leveraging your existing GIS content and making it available across the organization on devices people commonly use, such as tablets and phones, all done in a secured environment. Today, we'll showcase how you can use the ArcGIS for Utility templates to jumpstart your asset inspections and streamline how information is shared between the field and the office and across your organization. Let's begin by first outlining the common utility inspection workflow. Step 1 is organizing the information needed for inspections. But rather than pointing out or printing out maps, we organize our GIS data needed for the field and publish that to our mapping portal. This allows field crews to sign in and access the information on their device and conduct the inspection. This also allows managers to see the same information to monitor and track progress, enabling them to prioritize work and help ensure compliance. These three steps are common across electric, gas, water, sewer, and storm industries. In fact, we've packaged up 8 asset inspection templates that follow this common pattern that you can download today. We'll cover those templates at the end of today's presentation. For now, we're going to apply this workflow for the hydrant inspections, where we need to organize the hydrant data stored in GIS, deploy to the field, and make available for management to track and monitor progress. The applications we'll be showcasing for this workflow include ArcMap to organize the data and publish to our ArcGIS Online organizational site. Then we'll use Collector to conduct the inspections, and we'll use the operational dashboard to track and monitor progress. Let's break down the first step, organize. Organizing data is broken down into 3 tasks: prioritize, publish, and share. For hydrant inspections, we prioritize by identifying the hydrants that need to be inspected based off of their geographic location. We then publish the results to our organizational site and share that content with specific users within our organization. So rather than talk about this, I'm going to turn it over to Claire to demonstrate how to accomplish these tasks. Claire?
Thanks, Pat. To begin organizing GIS data for hydrant inspections, I'm going to use an application most of you will be familiar with, ArcMap. To create my hydrant inspection map, I'm using Esri's topographic base map. Having already signed into ArcMap, I've also added my water network map service. Additionally, I've added my hydrants and hydrant inspection table from a file geodatabase to the map. To better understand my hydrants, I've symbolized them by operability. Though I have this map view of hydrants, I'm still presented with a spatial problem. I need to be able to easily identify priority hydrants. In this case, I'm defining priority hydrants as hydrants within 300 feet of a critical facility, such as a school or medical center. To solve this problem, I can use a geoprocessing model. In this model, I'm creating a feature layer from all operable hydrants. I'm also filtering my facilities layer to include only schools and hospitals, and buffering these features by 300 feet. From there, I can select all operable hydrants that are within this critical facility buffer. These features are then added to a new feature layer, the priority inspection output. After the model is run, the prioritized hydrant inspection layer is added to my map. I'm now able to easily view where these priority inspections are. Having prioritized, I can now publish this service to my ArcGIS organization. Before publishing, I will remove the topographic base map, and I'm also going to remove my water network map service, since this is already a shared service in my organization. When I share as a service, because I'm connected to my ArcGIS organization, I can share this as a hosted service. Additionally, I'm able to add connection to another ArcGIS server. Because users will be editing this data, I'm going to enable feature access versus tiled mapping. I'm going to enable the create, delete, and update operations. And in order for field crews to take this data offline, I'm going to enable the sync operation. You'll notice that my item description has been automatically filled out. This is done by using the map document properties of my hydrant inspection MXD. Finally, within the service editor, I'm also able to select groups within my organization to share this service with. Having published my service, I can log on to my ArcGIS organization to begin to create the maps and apps for my hydrant inspection workflow. I've signed into my organization, Mercator Water, and right from the home page, I'm able to see some key maps and apps that are used in my utility. This includes the water and stormwater network viewers, as well as a mobile application, the Water Isolation Trace, which can be used by field crews in the event of a main break to determine which valves to shut off and which customers and hydrants are affected by the shutoff. I also have a public-facing application, my outage viewer. This allows the community the utility serves to view any planned or unplanned outages throughout the service area. To access my published service, I'm going to navigate to my content. From here, you can see the feature service I've just published. This information, such as the summary and descriptions, are automatically carried over from the published service. I've begun to create a web map to conduct hydrant inspections. This map is focused on a specific end user, field crews conducting hydrant inspections. Because of this, rather than enabling all of these fields in the pop-up for the user, I'm going to configure the pop-up so field crews view a description from one field. In this case, the facility ID. I'll then save the pop-up and save the map. The final step before users can begin to inspect hydrants with this map is to share it. Because the end user is field crews, I'm going to select the Field and Facilities Maintenance group. Now, members of this group are able to access the hydrant inspection map. This group also includes some key maps and apps to help field crews do their work. This includes maps to view network assets and maps for redlining and map change requests. Having prioritized inspections, published and shared the service and map, field crews can use this map on their device to conduct hydrant inspections. Pat?
Thanks, Claire. To recap, Claire used geoprocessing to prioritize the hydrant inspections. The geoprocessing model identified the hydrants that were near critical facilities, such as schools and hospitals, which created the list of priority inspections. Then, she published the results as a feature service and created a web map. Creating the web map enabled her to organize what information would be accessible in the inspection map. She then configured the pop-up for the hydrants in the web map to provide only the information the field crews need during the inspection. The goal is to make sure field crews only update required information. Finally, she shared the web map with the field survey group so that specific users within her organization can access the inspection maps. The second step of the workflow is inspection. Now, we traditionally focus a majority of our time and effort on this phase. There are essentially three tasks to this process: locate, inspect, and update. First, we need to locate the hydrant to inspect. Then, we need to conduct the inspection. Finally, we need to record and update our findings on the local device and sync them back to the office. Now I'm going to turn it back over to Claire once again to demonstrate how to accomplish these tasks. Claire?
Thanks, Pat. On my iPhone, I have installed the Collector for ArcGIS application. This is a freely available app for iOS and Android devices. I've signed in as a member of the Field and Facility Maintenance group, and I can now view all maps that are shared with this group. This includes maps such as the map change request and map notes. These maps are designed to allow users to add information about the service area and GIS data. Additionally, I have the hydrant inspection map that I've created. Because I had enabled sync when publishing the hydrant inspection service, I have the ability to take this map offline. When I view information about this map, I'm presented with the summary as well as a description that includes information and steps for how the user can interact with this map. You'll notice that when I open this map, the map view is automatically centered on my current location. This is because GPS is enabled with the app and on my device. And rather than using GPS, though, I can use an asset locator to search for and zoom to one of my hydrants. From here, I have the ability to collect new data. I can also get directions from my current location to this asset. Right now, though, I want to see additional details about this hydrant. You'll notice that my pop-up is limited to the facility ID. And now, with the release of the 10.3 collector for ArcGIS, I have the ability to view and create new hydrant inspections. When I view my hydrant inspections, I can view all historic records. In this case, I can see this hydrant has been inspected in January 2014 and March 2013. My next step to complete this inspection is to add the actual inspection record. This inspection is going to be stored in my related table. I can update the PSI, as well as update any of the fields within this record, such as, yes, paint is required, and yes, this hydrant is stamped. These fields are created using domains on each field to limit the number of options a user has. Additionally, I'm able to add just some general notes about the hydrant and its condition. In addition to notes, I have the ability to add a photo attachment. The final piece in being able to share the information about priority hydrant inspections with my entire organization is editing the priority inspections layer. I can simply mark that this inspection has in fact happened. When I hit update, this information was automatically added back to the feature service. This means that my organization will have access to this information in real time in all the maps and apps that consume the hydrant inspection service. Pat?
Great, thanks, Claire. So to recap, Claire used the Collector app to log into her organizational site to access her inspection map. When she opened the hydrant inspection map, she was able to locate a specific hydrant to inspect using the asset locator. This is a key capability when trying to locate a specific inspection while in the field. Now, you could always use GPS to locate your current position and find the nearest hydrant to inspect. Next, Claire created a new inspection using related table. This is a new capability of Collector, allowing you to create a new record for an asset without having to create a new feature. We can now track and associate all the inspections per asset. Finally, Claire showed the ability to go offline, which copies your inspection and base map content to your local device. As we know, this is a key requirement when conducting field inspections. There are times when you have to go offline due to lack of connectivity in the field. The good news is once you are connected to the network, you can sync your changes back to the office. The third step of the workflow is summarize. This is where we want to see all of the inspections done in the field to help understand the status and priorities of work. There are essentially three tasks to this process: monitor, analyze, and prioritize. We first need to monitor the results coming in from the field. Then we need to analyze the results to identify patterns and trends to provide us insight into the conditions of the facilities. Finally, we need to prioritize the next day's activities by reviewing the status of work and progress being made in the field. So once again, I'm going to turn it over back to Claire to demonstrate how to accomplish those tasks. Claire?
Thanks, Pat. As data is being collected in the field, it's important for operations managers to have access to this. This information is going to be key in order to make decisions. Using ArcGIS Online, this data is used in a web map to monitor and analyze hydrant inspections and their assets. In my hydrant analysis web map, I've added my inspection service. Right now I have a view of all priority inspections. In order to view only those that have in fact been inspected, I can add a filter. Additionally, as I used an asset locator in ArcGIS Collector, I can also search for assets within my web map. Here I can see my hydrant, as well as the number of inspection records. I can also open all of my hydrant inspections within the table. Here you can see the inspection that I just completed. In the web map, I also have the ability to perform analysis. One simple analysis I can do is a summarization of inoperable hydrants within fire districts. This analysis is going to allow operations managers to view this information about their network and assets in a web map. This information can also be shared with some key stakeholders throughout the service area, such as fire departments. When complete, the results are added to the map and is symbolized using proportional symbols. Right now, I'm viewing all of this analysis and information in ArcGIS Online. However, I can view this same web map in another application, Operations Dashboard for ArcGIS. Like the Collector for ArcGIS app, this is freely available. I can use Ops Dashboard in a web browser to view my web map along with some additional widgets. For example, I can view a count of the number of inoperable hydrants within my service area. I can also view my analysis results in another way. In this case, I'm viewing a bar chart. I can now very simply view that Fire District 1 has the most inoperable hydrants, in this case 20 inoperable hydrants. I viewed this in a web browser, but I'm also able to view this same application in the desktop application. I've also created some widgets for my priority hydrant inspections, including a list widget here and a gauge widget showing the number of hydrants remaining. In this case, 63 high priority inspections are remaining. So within this desktop application, that I can edit this operational view and add additional panels and widgets. Additionally, using this desktop application, I can begin to create and share dashboards for other inspection workflows and for stakeholders throughout my utility. Pat?
Great. Thanks, Claire. To recap, Claire first monitored the results by creating a filter in the web map to view only inoperable hydrants, enabling managers to see current operation status of the hydrants. Next, Claire used ArcGIS Online spatial analysis tools to determine the number of inoperable hydrants per fire district. This provides managers a better understanding of which fire districts are the most impacted by the status of the hydrants. Finally, Claire used the operational dashboard to communicate the results using graphs and lists within the operational dashboard, enabling managers to prioritize the next day of activities based off the status of the field inspections. Claire also highlighted that the operational dashboard can be accessed via a web browser, or you can download the desktop version. Okay, well, we've covered a lot of information in a short period of time, so let's take a moment to review the entire workflow. We used ArcMap to organize our GIS content and publish the hydrant information to our organizational site. Then, we share the hydrant inspection web map to specific groups within our organization. This allowed field crews to access this information on their mobile device using Collector. As the hydrant inspections took place, managers could monitor the progress and identify trends using the operational dashboard. By using the ArcGIS platform, you can modernize the way your organization conducts asset inspections and provide up-to-date, accurate, and timely information across your entire organization. We hope you enjoyed today's seminar. On behalf of Esri, I would like to thank you all for attending.